Hi, I'm Carlos Mestre del Pino, IT consultant at the Cloud Native team in ITQ, and I'm here joined today by Matt from Google.
Hi, I'm Matt Feigal. I work on the Google Cloud Platform team in the Netherlands, and I take care of our partners and customers to make sure that they're understanding and working well with our stuff. Carlos and I had a really interesting conversation at KubeCon in Valencia this year, and we thought it would be really interesting to share it with all of you. So here we are.
Yeah, exactly. And that conversation was about Google Cloud open source portability. So basically what is Google doing in terms of the open source components that teams tend to use with in their Kubernetes setups, and how Google is offering that. There are the different ways, manage services, run your own. So we're going to go deep into that.
Great. So how are we going to tackle this?
Well, yeah, I mean, as we know, the Kubernetes community, we really love open source software, right? And that's, not only because it's free, right? But it does provide, of course, with the ability to start small. You get lots of community support. There you also tend to have some flexibility when it comes to integrating with your existing systems. So that's one of the big points on Kubernetes, right? It's using all these very good open source components to strengthen your platform and extend it.
Yeah. And then what we see from Google is once people are fallen in love with this ecosystem and are really comfortable in using it, Google Cloud makes it a very easy place for them to extend their work and extend their clusters when they're ready to. Yeah. Or if they're building something new, start from a greenfield, from scratch situation. And we make it really easy to run those systems on us. So our idea was Carlos will give us an example of how he would walk through one of his customers with an on-premise environment. Yeah. Building up this stack, and then we're going to translate that onto Google Cloud.
Typical application architecture of what we would see on premises. Not necessarily for a specific application, but we're just going to go through diverse functionalities that you can add to your cluster. This is going to be our Kubernetes cluster. And, let's say you have an application. Typically, it's probably going to have a user interface. And then let's just drive a couple services. We won't give them name, we'll just keep it simple. Service 1, service 2, and then possibly UI might be calling both of those services. One service might call the other one. It can be any combination, right?
Okay.
As well, something that's been growing in popularity lately, it's running serverless services in Kubernetes. That's typically enabled by Knative. So let's just add that here.
Okay, so you've deployed Knative into your cluster, and then your developers are able to start just more easily throwing services there.
Yeah. Okay. So for example, we could have just like a third service in here, which might just be called by one of the other services. What's important to notice in Knative, lots of the times they're event-driven serverless containers. So you can, for example, do that. As if the user takes any kind of action, you could, for example, run function in the background or anything.
Great. So when you're running these services, I mean, say this is a retail site, you have shopping baskets, you have user state, you have lists, analytics. Do you store that in the cluster when you're doing this on-premise?
No. Okay. So typically, and that's what we're going to see in this column here, we're going to have some external services. Sometimes they might be deployed in the cluster. Sometimes just going to write here an external clusters. That's something that we saw. So maybe one cluster with that contains all the different services that all the other clusters will be using.
Okay.
And you mentioned the shopping basket.
Yeah.
So shopping basket is going to have catalog items, I guess, and that's possibly going to be on an SQL database, which perhaps one of your services will be connected to.
Okay.
Then extending this idea of the shopping basket, right? When you're on a website, you're adding all these products, right, to your shopping basket. But what happens if the container where your application is running crashes, or if you for some reason had some connection issues and you had to like refresh the page and stuff, you're going to lose all the objects, all the products in that shopping basket, and that's something that I think it's a bad user experience, right? So what you typically do for that, you would have some kind of caching solution. Let's just add that here. Typically, Redis, open source. What you can do, it's just caching your user session data, so that if anything goes wrong, you will always have the content of that shopping basket in.
Great. Yeah. More short-lived storage.
Yeah, exactly. Containers, they can be ephemeral,
just like your
ephemeral, right? Yeah, they can just die at any moment. Yeah.
Okay, cool. How are you managing the traffic between all of these for security policies, things like that, especially if you get external services from your cluster?
Yeah, that's a very good point. And for that, we use service mesh.
Okay.
And there's different types of service mesh, but the most popular one at the moment, we see that it's Istio. That will allow you a more secure service-to-service communication. But again, like you said, you might have external services running on a virtual machine. You want to be able to connect that to the service mesh itself. So it just has to use your legacy services as well, integrated with your more newer systems.
Okay.
And then as well, service mesh does, of course, allow you to do canary deployments, blue-green deployments, and just testing that functionality before you really push it into production, right?
Yeah, great. So what's next? Now, if I'm operating this system, I need to know what's going on, if I'm meeting my service level objectives, things like that. How are we doing this on-premise when we're not doing it in Google Cloud?
Well, there's a couple of services that you're going to use for that typically, which are Prometheus for the monitoring. You will also install a Prometheus node exporter in your cluster. Then you might have FluentD, which is used for distributed logging, and you might also install your FluentD daemon in here. And you typically might see as well from some kind of dashboarding solution that, Grafana is a very popular one, but it's not really the only one, but typically used in combination with Prometheus,
Okay. Cool. Now we've got a development team that's throwing stuff in and updating services all the time. What's their deploy street look like?
So that's one of the parts that we're missing, right? You're going to always want to automate the deployment of all these services, right? Especially if different teams are working for different services, you want to keep those processes differentiated, right? So we're usually going to have a CI/CD engine. And for that, there's a continuous integration, continuous deployment. And for this, there's not necessarily one industry standard, I would say. I mean, in lots of on-premise VMware environments, you see Concourse quite a bit.
Okay.
But then, I think FluxCD, Tecton, they're all very popular.
Okay, so it's just a whole range of them that you see at your customers.
Yeah, exactly that. There's less of a clear choice when it comes to CI/CD at the moment.
Okay.
And of course, that's only going to be the automating part, right? But you're going to automate the build of some container images.
Yeah.
And those images, you're going to put them in your container registry, which in an on-premises environment, it's typically going to be Harbor.
Okay.
So let's say we have most of the services in here, but we left one.
Yeah, there's a red one left. What's that one?
Yeah, exactly. That's going to be your S3 storage, so simple storage solution, and we typically see Minio. There's a reason why I also made this one, these two in different colors, and that's the fact that we typically see all of this deployed in Kubernetes itself. When it comes to storage, there's a little bit more of a discussion going on, and lots of times we see it just running on VMs.
Yeah.
But as well, possibly in Kubernetes, but not preferably, I would say.
I feel like this is a continuing, ongoing debate of where do I store my
Yeah,
stuff?
where do you
Is it
store
safe?
where
Is
do
it
you
safe?
store your
Yeah.
data, right?
Yeah.
Well, I think Kubernetes is great for lots of things, but perhaps not for storing your data quite yet.
Okay.
Let's say.
And so Minio is just API compatible with S3 and the other storage.
Yeah, that's correct. It's
good.
a typical S3 that you would know.
So from a developer, I just use it as any other storage bucket, any blob storage, but underneath your operators are keeping it alive for me.
It's just like a file system you would have in a typical computer, but just completely separate from any compute processes.
Okay. Cool. Nice. Great. That seems like a good spot to switch over now and talk about where we would map these to Google Cloud stuff. I have these conversations a lot with customers and partners, and some things I would hear sometimes if I'm pitching why Google is the best place to run this stuff, they'll often say things like, of course we believe that Google is the best place to run our Kubernetes cluster because you are some of the inventors of it. You've been running managed Kubernetes in production for 7 years? 7 years now, as of last week. And yet then they say, but we can't because. And there's always a whole bunch of reasons. And several of them for the techies are things like the cost of switching. They're worried about the cost of switching. They feel like bringing this over is going to be very challenging, expensive, require a lot of re-architecting. There's also the cost of sort of the mental change of updating their mental models and how they run operations, and they're worried about that. And that's just in the tech side. There's some other business drivers as well. But I think hopefully what we can show is actually the cost of switching in a situation like this is very low. Yeah. So if you're needing to move something or extend something, it's very minimal impact. And if you are just taking your existing knowledge and building something new here, it's then even easier for you as a developer, or as an engineer. Yeah, so let me start mapping it out. Yeah. So I think the first big and easy change that we make here, right, is that instead of Kubernetes, well, I mean, you're still running Kubernetes, but what you're running is Google Kubernetes Engine, or GKE, which is a fully managed Kubernetes environment. That means that we're responsible for the master, the nodes, the upgrades over time.
You're doing the whole life cycle of it.
Yeah, everything around that, including things like, you mentioned that you've got daemons installed on the nodes. Like these things then become sort of included in the nodes that you don't need to worry about them, and we are keeping them alive, responsible for them, and you don't even need to see them anymore. There's a couple other really interesting. So your application services, right? You've got these mapped out as deployments or deployment scripts from your CI/CD system. Yeah. All of this maps over pretty much exactly. Like all of your deployments, all of your configuration, all of your policy that you've run, because you're writing and deploying your application towards the Kubernetes API. Yeah. Assuming you're not playing around below the Kubernetes AI in your cluster, all of this will map over like one-to-one extremely well. You could I've seen customers just update their deploy pipeline, and they're suddenly running fully on Google Cloud without touching any of this. A few other interesting benefits here next to that is I've seen a customer in the Netherlands, which was a gaming company that had a big cluster here in the Netherlands, but they wanted to reach an Asian market, and they're having terrible latency problems. So they're just able to extend, their Kubernetes cluster into running on GKE in our Asian data centers, and immediately they probably don't deploy all of this, but just by deploying all of these services, immediately have improvements, and then it's because it's all the same system. Yeah. It's consistent security policies, consistent configuration. When they roll out here, it also rolls out there. Yeah. Like it takes all of this mental math and complication out of making this from your core system into a global system. So it's super great for the techies for the immediate win backs of their mental cycles that they need to run the system. So I think I could talk for another hour about why Kubernetes is good for this, but let's go on to some other examples. Because
you would then typically use, I guess, a service mesh for connecting.
Yeah, exactly. So you're going to need, you need some consistent management between these, and a lot of that happens at the GKE plane. Yeah. But you're also going to want to make sure that between these clusters, let's go here instead. that between these clusters, you've got good connections, and all of this stuff that you're covering with Istio, policy, retry things, monitoring that network traffic, that maps over to us to something called Anthos Service Mesh, which is a managed version of Istio.
Yep.
Like you run a command line or you click a checkbox in the console as you prefer, and we are then deploying the Istio. We're being responsible for the Envoy sidecar proxies that go into each container.
Yep.
We're deploying your service mesh dashboards and things like that you then have access, just as if you had deployed it on premise. So does that answer your networking and Istio question?
Yeah, absolutely.
Cool. Another big highlight, you mentioned that your people are really in love with Knative.
Yep.
So you've got a bunch of your developers running on Knative. I'm actually going to carve this out. If we deployed Knative in our on-premise cluster and we map those deployments over, it'll keep running just fine in GKE. But we actually have probably an even easier way to run this. We're going to carve this out of our Kubernetes cluster.
Yep.
And we're actually going to deploy this into Cloud Run. And Cloud Run is designed from the ground up to be API compatible with Knative. So anything you've deployed, written to deploy to Knative, will just map over immediately to work with this. No changes needed. And it doesn't. Then it's not part of your Kubernetes operations responsibility.
Yeah.
We're fully responsible for it.
Separate. Yeah.
You mentioned events as well.
So for example, I think you could have some containers that are just like completely event driven.
Yeah.
And I think for that, well, Cloud Functions would as well be a good solution, which is even an abstraction built over Cloud Run.
Yeah, exactly. Right? So Cloud Functions, when it started, was a whole separate stack. But about 6 months ago, we updated it. So Cloud Functions is actually running on top of Cloud Run.
Yeah.
Right. So if you've got this event-driven function here, you deploy it into Cloud Function, and actually it's being managed and operated in the same way as all of your Cloud Run stuff as well. So all of that stuff you've done will map really nicely into this. And then it carves out that your team then focuses more on these things in Kubernetes for the operations stuff.
And I think also what's probably still important to mention is that, Cloud Run and Cloud Function, it's not managed Knative, but it's you can completely map. You can just define your Cloud Run services just with the Knative service definitions, right? So it's fully compatible.
Yeah, exactly. So you've already done this work on premise, it maps out. And if you need to leave someday, or if you need to run it somewhere else, because you've done these Knative definitions, you can put it anywhere you need to.
Yeah.
Because we were talking about operations, let's continue a little bit about operations.
Yeah.
Prometheus and Fluentd is where you're doing a lot of operations.
Yeah.
If you are moving this stuff over into Google Kubernetes Engine, you immediately benefit from something we call the Cloud Operations Suite. I'm going to put it over here. Cloud Operations Suite. And all of this stuff from Fluentd and cluster services and event logs and stuff that you're used to are getting pulled in for a central set of monitoring, logging, alerting, SLO tracking, through even tracing, like tracing and debugging moments, is done through something we call Cloud Operations Suite. And even your extra cluster will automatically be pulled in there. If you're running MySQL or Cloud SQL, everything gets pulled in there. However, you mentioned that your team is massively in love with all of the open source stuff. Yeah. And this is like Google managed, we love it. But if you're in love with Prometheus and Fluentd and all of these things instead of using our suite, we're still using Fluentd here in your notes, so nothing changes. But all of your Prometheus stuff where should I draw it? It's actually not in the cluster, but all of your Prometheus stuff is also fully managed because we know that the community is massively in love with this and we don't want to take it away from them. Right? So
I think even in the same prompt where you can just send your queries for Google native monitoring, you can add Prometheus. Prometheus queries, right, with that managed service for Prometheus.
Yeah, exactly. And in fact, these things actually are talking to each other as well, so you can go back and forth between them as you need them.
Yeah. That's correct.
So I think we've covered the Prometheus and the Fluentd. I'll just put a star there.
Yeah.
Maybe storage. Redis SQL Server or Postgres,
Yep.
Minio is probably the easiest, right? We have something called Google Cloud Storage, and all of these things are fully API compatible.
Yeah, it just maps.
Yeah. And then your operations team doesn't even need to think or worry about that. Like, we're fully responsible for that. I mean, I guess you could install Minio on a VM if you wanted to, but I think it's a waste of energy.
It's probably, no, I agree. I think it's better to take just directly the managed service from Google. That will also do wonders for scalability, availability, reliability.
Yeah, exactly. For your SQL database, we typically see customers make different decisions. They might just install SQL on a VM or SQL Server on a set of VMs and run it because they've got experience with that and they're confident. We also have a Cloud SQL, which is a fully managed SQL database, and underneath it's running Postgres or whatever, or MySQL, and we're managing it for you. About 6 months ago, we launched something new, though, that might be better if you're looking to be as hands-off as possible. We launched something called AlloyDB, which, just like the Istio story or the Knative story, is fully API compatible with Postgres and the others, but underneath the implementation is different. And you don't need to know about that or care that, but it means you're getting better performance, better reliability, just by using this, and you don't need to know anything about it, and the cost of switching is small because it's API compatible. If you need to move away, you push out your data somewhere. Yeah. So I think which would your customer choose in this case?
I mean, I think, if they're really just kind of doing some kind of lift and shift or just trying to minimize, those changes to the applications, they would definitely go first for something like Cloud SQL.
Okay.
If they really have scalability needs, they might even use Spanner for SQL.
Yeah, true. I missed Spanner is in there. I do feel Spanner is really good, especially if you're like that gaming company doing global operations. Yeah. But it is a bit of a bigger architecture change, and we're trying to keep the cost of change as small as possible in the story.
So, absolutely.
It's just it's more about a little bit of the application design changes. So, but thanks for thinking of that. And Redis, Redis again will map out to Memory Store, which is a fully managed Redis environment.
Like caching,
Boy, I shouldn't show any hesitation in a video like this, but what I believe is that Memory Store is fully managed Redis, as opposed to, for instance, AlloyDB, which is fully API compatible, but it's a different implementation.
Exactly. This is fully managed Redis.
Yeah, cool. Thank you for knowing that. It's my job, but Carlos is really good at this. I see. This comes to, I think, a really fun part, the one we haven't touched yet, which is the CID system. Is there anything else we're missing here that we should be talking about before then?
No, I think we can look at that automation for the integration and container image build.
Yeah, good. This is one where I see, like what you see, is that every customer I talk to has their own opinions and their own specific needs or their own culture, and they've developed their own collection of tools to do this. And let me map it out over here because it's a bit more complex. But typically, you mentioned several tools: Tecton, build tools, deploy tools, container registries, artifact registries. And so I'm going to draw out kind of the canonical Google suite. But please keep in mind, we know every customer is different. So typically, every customer will use one or two or some of these, and then plug in their own where they massively love it or it's really critical to their operations. So the typical as you've got your source code, you've got your source that your developers are working on, Git repos, source repository built in if you choose to use ours, or it can synchronize with yours. We have something called Cloud Build, which can listen for triggers when you push new versions. And sometimes you'll have your application code here, and sometimes you'll have your infrastructure service configuration. Yeah. So we have a Cloud Build, and that's just our build system that will take your code and build it according to your definitions. It will wrap it into containers. So if you're deploying stuff here and you don't want your developers to actually have to worry about Docker files, they just write their code and their dependencies. Cloud Build will take care of that. or you can customize it if you choose.
Yeah.
So after you've done your cloud build, that will typically dump into an artifact repository, which we used to call container repository, but now we call it artifact repository. So that's really clear. Fact repository.
Yep.
And then you have cloud deploy, which is listening for things like that. Typically, you would build in your automation testing or your manual steps or things like that. So Harbor maps to Cloud Artifact Repository. Cloud Build and Cloud Deploy map in here. And that would be the typical story. But if you said, well, we use this instead, we're in love with, insert Harbor, insert JFrog, whatever else you have here, you could swap this out. There are some really good benefits to this, such as if you're working in a regulated environment and you need to know that your artifacts are signed before they get deployed, you need to know, have that consistency and rules like that. You get that automatically. So I think that's the whole story. Yeah,
I think we pretty much covered everything. And I think, what's important to notice in here is that it's actually never black or white, right? Like it's never really, or it's hardly ever going to be, this setup or then the one that you've been drawing over, right? Like most of the times we're going to see a combination of mix and match of all these different solutions, right?
Yeah, absolutely. In fact, I almost never see a customer move everything all at once. Like even if they fall in love with this and make a big push and do this all at once, there's still going to be some service or virtual machine that they're talking to at home or in a different environment. So it's really a step-by-step approach as it makes sense. And I try to drive it by when will the tech team get the most win back. Like, hey, by doing this, you're going to save a ton of energy, which then you can put into the next phase. So that's the way I typically help people structure these projects.
Yeah, I think it's important to not only look at those resources that you have as a company, or even the set of skill sets that you might have across your different teams, but where are they wasting their time, right? Where really, where's that burden, right? What is there a component that's constantly kind of breaking or giving you any kind of issue? Then that's probably the first thing that you're going to maybe take as a managed service, right?
Yeah. As a managed service, yes, because then you win that back. So if I'm allowed to sell ITQ in this video a little bit, a really big thing I see customers bump into here is they are in so much pain on one of these topics, right? This team managing this or this team managing this is so overloaded that they can't make the change, or their management can't give them the room to change. And this is typically a spot where everyone knows it needs to happen. They believe that once it's done, they're going to get all this time back to do the other more important projects, but they can't make it because they're trapped in the mud pit. And now here's where I sell a partner that we work with, like ITQ. As much as customers want to do everything themselves, this is often where I say, hey, actually what we need to do is give you a little burst of help. We're going to bring in a team of experts that are going to help your team move this piece, which is causing a lot of pain. They're not going to take your jobs away. They're going to help you move it and teach you what they did. And that will often unblock that first stuck in the tar pit problem to the point that now then the team has some of the knowledge and the time available to continue this on their own, which is a really nice solution for tech-minded customers.
Yeah, we can also help our customers even going through that decision process of what are the first things that we're going to move.
Yeah, that's true too. Like when you're in the middle of it, you can't see where the biggest pain is.
Exactly. It's with someone that's a little bit far behind, get a little bit more of an overview.
Yeah, true. And this is always, I think, my most fun part of the job is like helping people figure out how to unblock the things where they're feeling the most.
Yeah. So, no, absolutely.
Cool. So what do we have? Maybe we each want to have a final takeaway. If you looked at this, what was the biggest thing that you would tell customers you have to pay attention and get this part right?
I think again, it's all those components that might be a burden on your team. Sometimes, across teams that manage platforms, we would say typically databases would be something like that, or the cloud storage, So also because of that discussion of where do you run your data, or sorry, where do you host your data, right? So sometimes it's good to like just get that outside of the cluster, take a managed service, and just kind of focus a little bit on your own, important things.
Yeah, cool. I think mine has changed over our conversation, and now it's a lot of techies really like to have their hands on all the knobs, and I totally get that, but when it comes time to switching towards managed services, they often don't want to move because they're worried about not having that control, and they're worried about lock-in. And the mindset I suggest is think about actually where else you could be putting your energy in your company to help your company by using these managed services. And don't be afraid of coming to an environment like this because you're thinking you're going to get locked in. It's really minimal. Instead, if you are evaluating that lock-in question, look instead at what's the short and midterm benefits we are going to get as a team versus the eventual cost of moving out. I hope that you all enjoyed this conversation that Carlos and I got to continue from our KubeCon chat earlier this year, as much as we did. If we've grabbed your attention, you want to try any of these things, prove it to yourself that it's as good as we say, I think the best spot to start is g.co/codelabs/cloud, where you can find hands-on labs on just about any of these topics to check it out and dig in yourself. And Carlos, what do you have to share? Yeah,
I recently, went through this process with the application of a friend of mine built. And I wrote a blog post about it that you can find in the description of this video. And as well, if you do attempt to do it and you have some questions or you want a sparring partner to go through some of the process, you can always contact me. And I just want to thank you, Matt, for coming to the IT Gear studio today and having this nice conversation.
Thanks a lot for having me.
And thanks everybody for watching.